Hello everyone. Welcome back to Dr. Liu's VCE Physics channel. Today, let's learn together about the 2025 VCE Physics examination. We will focus on questions related to gravitation and planet motion. My explanations may be flawed. If any teachers, parents, or classmates find errors, please feel free to provide your guidance. When a satellite is in orbit, the only force acting on it is gravity. This force is always directed toward the center of the Earth and remains perpendicular to the satellite's velocity. Therefore, the gravitational force does zero work on the satellite. To find the period, t, use Kepler's third law for a circular orbit, rearranging for t, substitution. The gravitational force is calculated using Newton's Law of Universal Gravitation, substitution. Mark 1. Newton's second law. According to Newton's second law, an object must accelerate in the same direction as the net force acting upon it. Mark 2. Force identification. The only significant force acting on the satellite is the gravitational pull from the Earth, which acts as a net force on a satellite. So, the satellite is accelerating towards Earth. Mark 1. The assumption Tom assumes that the gravitational field strength, G, is constant at 9.81 n a kilogram throughout the entire 250 kilometers ascent. Mark 2. The effect this assumption leads to an overestimate of the value of W. In reality, the gravitational field strength decreases as altitude increases, meaning the actual force required to move the spacecraft becomes progressively smaller. Satellite in circular orbit. Orbital radius. This is calculated by adding the Earth's radius to the satellite's altitude. Orbital period, t. The orbital period of a satellite around Earth is calculated by Kepler's third law. Gravitational force, Fg. The gravitational force is calculated by the universal equation. Conceptual mechanics. Acceleration. Based on Newton's second law, the satellite accelerates toward Earth because gravity is the net force acting upon it. Work done in orbit. Because the gravitational force always acts at perpendicular to the satellite's velocity, it does zero work during a circular orbit. Work during ascent. The Tom case. The assumption, calculating work as a simple product of mass, height, and 9.81 assumes that the gravitational field strength remains constant throughout the entire 250 kilometers climb. The effect. This logic leads to an overestimate of the work done. In reality, gravity weakens as altitude increases, meaning less force is required to move the spacecraft the further it gets from the surface. If you need my help, you can add me on WeChat or WhatsApp, or send me an email. Thanks for your attention. Please note Dr. Liu's VCE Physics channel, Dr. Liu's VCE Chemistry channel, and Dr. Liu's VCE Biology channel.